Alright, we're going to take a quick look at, well, I was just going to show GR-ADSB because I wanted to do some more videos on GNU Radio using the bladeRF, but someone threw out Ham2Mon, no pike on Twitter, should say, uh, which caught my attention, and so it's a GNU Radio-based SDR scanner for narrowband FM demodulation. It also does airband AM modulation, which is what I'm going to try and show really quick. Not a lot of traffic going on right now, but you need to grab this particular fork here, which I'm about to pull down into DragonOS Focal R15 because it is made for Python 3 and GNU Radio 3.8. And so we're going to pull this Ham2Mon down, and you can read about it and see what it's going to look like here once we get it installed. And then while I was reading, I also came across a GUI for it as well, a front-end GUI, although I've only seen it work, and it's probably something I'm doing wrong. I'll at least show how to install it. So we're going to grab this as well. And then finally, we will fix GR-ADSB that's actually in DragonOS Focal. The part that needs fixed is for the web server portion. Real easy fix. For this Ham2Mon GUI though, we're going to grab NPM, which I've already installed to save a little time here, but you do sudo apt-get install npm. And so you can see I've already got it. And we'll knock out this Ham2Mon GUI first because it takes a little longer. We need to see if we look at the page here. We change into the Ham2Mon GUI. We do an npm install. I'll let that go. Let's see. You are probably going to get, or for sure going to get, warnings at the end about vulnerabilities. You can try and fix them with the commands that it gives you, or maybe manually, or if you're really that concerned, try and pull in newer packages and see if it works with this Ham2Mon GUI. Alright, we can see it talks about 87 vulnerabilities. I'm not that concerned about it with this. There's probably some other ways to do it. I'm just not that familiar with npm. So we're going to change into server and we'll do another npm install. While we're in this folder, we'll copy the config sample.json to a config JSON. Use nano or whatever you want to do, use to edit this file. And we're going to tell it, and I know there's a trailing slash here, I'm not sure that that is needed, but we're going to tell it where the wave directory is, and what that's referring to is the other Ham2Mon package that we downloaded. It has a folder in it called apps, and in there is a folder called wave, which is where the wave files are going to be stored. We'll come up a directory and we'll do npm. I always forget it's not directly build, it's npm run dash script. I guess I should make this a little easier to see. Build. We'll let that build, and while that's going, we'll jump back over. We'll open another terminal. Hopefully we can catch some traffic here. We'll change into our Ham2Mon. You can see there's that apps, and then you see the wave directory that's there. We'll open up with GNU Radio Companion just to take a look at some of the GRC files to look how complex these are, and the individual put a lot of effort into this. So this is what the flow graph looks like, at least for the AM flow example. There's the narrowband FM example as well you can take a look at. But we're going to call the Python file directly. And before we do that, since this Ham2Mon GUI finished, we'll do an npm run production. Open up the link talks about here. And so this is the front end, which should look in the directory in the WAV files, and it should come down here and show the frequencies. We'll see if I can get it to work this time. I'm not sure what I'm doing wrong. I've tried with and without the slash I was talking about. So back over to Ham2Mon. I'm going to cheat here and use a command that I copied earlier once I figured out what was needed for the bladeRF, because it needed these arguments here, bladeRF equals 0, and I needed to change the AGC mode to manual. -N is how many demodulators we're going to use, so we can look at 4 channels at a time within the 4 meg that we've specified there. I'm looking at the center frequency of 127 megahertz, gain, let me think, squelch, volume, forget what the -T is. The D is, in this case, 1. We're doing the AM modulation, and then -W is to write the WAV files. Again, you can see what it was tested with. I'm going to go ahead and test it with the bladeRF, so I can add that to the list. I stole some of the examples here and then just modified it as needed for the console operation. And then, because I can never remember all the GUI controls, I'm going to just cheat and look at that here. So we're going to use Python 3. We're in that Ham2Mon apps directory. I'm going to open up the bladeRF. And let's see if we can get some audio. So gain, let's see, RF gain, G and F. So let's go the other way. Alright, I know there was some traffic earlier. Let me take the, let's see, what is that, E? Or no, sorry, R. What is R? Detection threshold. Alright, so don't know if you heard that, but let's see, volume. Try and take the volume up some, so you're going to have to mess with the gain, the detection settings. There's squelch. Okay, so as that locks onto that channel, it's then, we'll open up one more terminal window just to show in Ham2Mon apps wave. We can see those wave files are being generated there automatically. Now over here, what should happen is those wave files should come over here. So I'm not sure. So wave directory. Let's see. We'll try it one more time with the kill this, and we'll edit this config.json file. Let me just make sure. Ham2Mon apps wave. Nope. Oh. Home Dragon Ham2Mon apps wave. Alright, we'll run again. So it sees the wave directory. Shoot. Hmm. Well, this part is working. I've had it come up one time with a frequency listed there, and I'm hmm. Well, I can keep clicking, but I'm sure it's going to do nothing. Hmm. All right, well, I think we get the idea there. Um, I'll have to do some more research on this and figure out what I am doing wrong. Hmm. Okay, all right, so last thing here, let's take a look at GR-ADSB. I'll shut this off here. We go into the user source GR-ADSB, and let me see, web. So in DragonOS Focal R15, um, I did not install these next couple packages here that you need, and this will fix the web page of GR-ADSB. So you should do a sudo pip3 install. I'm pretty sure it's Zope proxy security and location is all that you need, which I did actually do just prior to this video. So I've already got everything that's needed there, and then we'd use Python 3 to open up the web server, and that should be running on port 5000, I believe. Alright, so there's the web server up and running. We can open up another, let's see, might as well shut this off. We'll go user source GR-ADSB. We'll go in the examples and we'll do a GNU Radio companion ADSB rx.grc, and this is what we'll get. We're gonna throw out an OsmoCom source here. We'll tie this in, and we need to reference the variables. So the sample rate, we got FS, which you can see up here, variable 2 meg. We'll hit apply, and we'll change this to FC for the frequency variable up there. And sometimes you gotta check. I can see that it did not change here. I'm not sure why that does that sometimes. So I'll go ahead and hit it again, and now I can see it change to 1.09. We also need to get the bladeRF arguments in here. So we'll do bladeRF equals 0, comma, AGC underscore mode. Actually, no. We'll leave that just bladeRF. Make sure that that applies. Open it back up. No, I'm not sure why it does that. bladeRF equals 0. Let's make sure it applied this time. Okay, we can see it there. Let's, for the RF gain, we'll type in gain so we can use the Qt GUI entry on that. We'll make sure that that took, which doesn't look like it did. It's not really liking me. So gain, try again, apply, okay. We'll disable this, and one more thing now that I think about it, we'll do antenna. So I'm going to use RX1 on the bladeRF, hit apply, okay. And it's going to ask to save this. I'll save it right to my desktop. I'll overwrite the old one. And let's see, we should hopefully get some results here. So it's on automatic gain right now. Let me see. Let's take it. Let's try it off of mode equals manual. Let's try something here. Suppose there could not be a lot of traffic. Let's see. Gain RX2. We can go in very chunks of or 2, 4, 6, 8, so on and so forth on the sample rate. Well, there we go. Alright, now we're getting some information here. So if we look over here, we let it run long enough, we should start to get some information here. There we go. Now we got, alright. So now I should have enough information here. At least got one on the map here. Now we got two. Got some of the information here. Now I know there's another, well actually it's built into DragonOS as well, another way to do ADSB with the bladeRF, which is maybe is recommended more so over this, being that there's a FPGA specifically for ADSB and then a tie-in to dump 1090, and that's included in DragonOS. But I was interested more so in using GNU Radio and tying this all together, especially after seeing the Ham2Mon earlier. So now we've got some information on the flight, call sign, and lat, long, speed, and heading. So there's probably some tweaking that I'm just not as familiar with the bladeRF and the gain settings and manual versus automatic that may need to be adjusted. But you can see it's pulling in the source from Osmocom and then pushing it out to the ZMQ message sync and then tying into that Python web server. Alright, well, that was a lot, but that's, well, at least two different GNU Radio applications and how to use them with the bladeRF. Alright, thank you.